So let's go back to Universe Sandbox. I'm going to show you some really cool stuff. We're going to open up a brand new simulation where we're going to bring up. I'm just going to change my lighting a little bit. There we go. I'm going to start with the Earth. Oh, you're very welcome for the advice. Thanks for asking. I'm here to answer honestly anything. I've been doing astronomy and space stuff since I was like 8 years old, so I've had a few years of practice. Can I explain the Northern Lights? Yeah, I can talk about the Northern Lights. I'm just going to show the Earth and the Moon first, and then we'll talk Northern Lights. Okay. So here is our Earth. This is what it looks like, and we also have our Moon. Our Moon is about this big compared to the Earth. It's about a third to a quarter of the size of the Earth. And it's not this close, actually. It's pretty far away. When we see the Moon in the sky, it looks really close. But in reality, the Moon is really, really far. It's about that far. It's 300, whoops, let's bring up the orbit so we can see it. It's 384,000 kilometers away from the Earth. That's how far away the Moon is. To get there on a rocket ship, it would take 3 days. To drive there, quite a long time, probably a couple of weeks, right? And Earth is pretty big compared to the Moon. Interesting thing, though, is that our Moon is actually, compared to the Earth, is one of the biggest moons in the whole solar system. Like if you look at a planet like Jupiter, which I'll actually show you. Here's Jupiter. Jupiter's much bigger, right? The biggest moon of Jupiter is Ganymede, which is also the biggest moon in the solar system. And so this is how big Ganymede is. Okay, so look at this. Ganymede is really small compared to Jupiter. Our moon is pretty big compared to Earth. Okay, so our moon compared to Earth is actually really huge, even though it looks a lot smaller. Ganymede, the biggest moon in the solar system, this thing's actually bigger than the planet Mercury. And of course, you can see how big Jupiter is. Right, so Earth would fit into Jupiter about 1,000 times. So I'm going to come back to this in a second, but I will talk about the Northern Lights just a little bit. I'm going to actually bring up a web page so I can show you space. I think it's called Space Weather. Okay, let me... Yeah, sorry, Olivia. Yeah, Earth is huge compared to the Moon. You spoke too soon. That's okay. Earth is still pretty big. Earth is still a big planet. It's the biggest of the rocky planets in our solar system. It's bigger than any moons in the solar system. It's a big planet, no doubt. But our Moon is pretty big, even though at first glance it looks kind of tiny. Thanks for pointing that out, though, because it's good to talk about those things. Okay, so let's go to space weather. On the website. So space weather gives you a bit of a forecast about auroras, which are the Northern Lights. The Northern Lights are known as Aurora Borealis, which means literally Northern Aurora. Okay, and that's compared to the Aurora Australis, which is the Southern Lights. So here we have, let's see, Aurora alerts. There's a really good, what I want is called the Aurora Oval. Here it is. Okay. So if you scroll down, you can click on this thing here. This is called the Aurora Oval. And is it going to load? It might not load. Oh, there it is. Okay. So this is actually showing. Sorry, I'm just going to fix the image a little bit. There, I'm just bringing it up a bit higher so you can see it. There we go. So this is where the aurora is literally right now. And you can kind of see, here's Ontario down here. And the Great Lakes are down here, and here's where we are. There's like Niagara Falls right there. I'm a little bit further north from you guys in Orangeville, but not too far. But so you can see that we're pretty far away from where you would need to be in order to see aurora. So that's one problem. And the other problem is if you look, the brightest color is only at about 30 to 40% chance of aurora. So in order to actually see auroras, you need kind of two things. You need dark, clear skies, and you also need a very active sun. The reason that we have auroras is because of the sun. Okay, here's the sun. It's also pretty big. I'm sorry, Olivia. I'm going to make things seem really small. There's the sun. The sun is huge. And look at this. Oh, there's our second moon. We're going to get rid of this guy. So look at the Earth. There's the Earth. Earth fits into Jupiter about 1,000 times. And the Earth it fits into the sun about 1,000,000 times. The sun occasionally has these dark spots on it called sunspots. I don't think we can see any right now, but Sunspots are places where the sun, which is like a big magnet, the sun's magnetic field is kind of tied together. Long story short, it means that the sun spits out all kinds of crazy radiation into outer space. When that radiation travels all the way to the Earth, instead of causing us grief and burning our skin or destroying our electronics, the Earth is like a magnet as well. And the Earth's North Pole and South Pole pull all of those dangerous particles from the sun up to the north and down to the south. And instead of causing damage, they create the northern lights. That's why you can always see the northern lights above the North Pole and down where the South Pole is, okay? And so the reason that we can see aurora is because the sun is spitting out all this radiation. So when the sun spits out more radiation, as you can imagine, we get bigger auroras that are also more visible to the south, okay? So in order to see the northern lights, we need a strong sun to fire lots of particles toward the Earth to make the northern lights, and you need dark skies, which, because it's summertime, it's not going to get that dark, especially up near the North Pole. So what that means, all of this together, all of these things that we talked about mean that the best time to see the aurora is actually from September to about December. And you can only really see them when they're very strong. And unfortunately, right now, the sun is just past its minimum. The sun actually goes through an 11-year cycle where it gets stronger and weaker. And it just passed the minimum. So in the next few years, it's going to go back up. It's going to produce more particles. We're going to get bigger aurora, and they're going to push further south, which means we might be able to see them. Okay, so that's kind of the gist of the aurora. So let's go back to Sandbox. But what I will say is that I've seen the aurora a few times in my life, and one of the best places I went to see them, I've seen them from Toronto before. Very rare, only maybe twice in my life, so they're not easy to spot. But if you do ever happen to go north, I was actually in the Yukon Territories, which is right about here, a couple of years ago, and I saw them very clearly from there. It was really, really neat. So if you do want to go and see them, the best places to go are anywhere far north. Like Iceland is I think that's Iceland right there. Norway is a really good spot to go. This is Norway here in Scandinavia. And basically anywhere in the Northwest Territories or Yukon Territories, you can go and look for the Aurora Borealis. Okay, and it's always going to happen. There are always auroras happening. So you've got a lot of time in your life to go and see them. It's not like a comet, which sometimes can only happen, once in 100 years. Right? Lots of different things. Oh, hey, we got a question in the chat from Jenny B. Hi, where can I find more stories about the constellations? Well, the amazing thing is that the constellations, the story that I told you is a story in what's called Greek mythology. So 3,000 years ago, or rather about 2,000 years ago, the ancient Greeks, they had their own stories about constellations, and they wrote these stories down, and today we tell these same stories. But different cultures all around the world have their own constellations. And so I want to actually show you some of the other ones that we have. And by the way, this program is Stellarium. I'm just writing in the chat here, .org. So if you go there, you can get this program for free. And if we go to the viewing options, we go to Star Lore. Look, these are all different cultures. Inuit are native Canadians, so we could bring up the Inuit Star Lore. And if we show the constellations now you can see a few different types of constellations. So they actually see the Big Dipper as a caribou, and they have their own story about the caribou, or about to and front. Now, I'm not as well versed in stories from all these different cultures, but I guess the answer to your question about where to find more stories is that there are a lot of books and websites that have stories from all these different cultures that you can talk about. And so you could talk about Native Canadian Inuit stories, Anishinaabe stories. You can talk about stories where maybe your family originated from a few hundred years ago. My family came from Europe, and so I can look at what these European cultures had. But there's different constellations for every culture all around the world. You can find different stories about the same stars. And so there are other Greek constellations that you can look at, but I always like to go and visit some other cultures and take a look at what they have to offer too. Lori says, love the story about the bears. Thank you. I'm glad you enjoyed it. It's the first time I've actually done it with pictures, so I wanted to add a little bit more brightness to it.